Hello everyone. We'll wait for a few more minutes for this to join. I have allowed your microphone, so if you have any doubts till the time we start the session, we can discuss them. And I've also shared the links of the previous week's video and the lecture slides, the folder link. I've shared it in the chat section. You can access that. I hope my screen is visible and the slides are changing as well. Can one of you just confirm if you can see my screen and if it is working well? I'm audible to you, right? Yeah, okay. My microphone is working. All right, let's start the session. Hello, everyone. Welcome to the weekly discussion and doubt clearing session number 7 of the NPTEL course on concrete technology, NOC24-CE46, which is taken by Professor B. Bhattacharjee of IIT Delhi. I am Ashirbad Satpathy. I am a PMRF research scholar at IIT Delhi, and I am also the officially assigned teaching assistant for this course. What I do is I take these weekly sessions of 2 hours where we discuss the various assignment problems that have been given to you in the previous weeks, and the deadlines have passed for them. And we also take up the doubts that you might be having regarding the previous week's lectures. There is another teaching assistant to this course. His name is Debojyoti. He usually takes his sessions on Saturdays from 6 to 8 p.m. and I take my sessions on Mondays from 6 to 8 p.m. As I mentioned, I have also shared the links of the previous week's videos and the lecture slides in the chat section. You can check it out if you want. Right. In today's session, we'll be discussing the week 6 assignment 6 problems. The week 6 lectures were regarding the different methods of concrete mix design. You were taught the Indian Standard Method, the British DOE method, and the American Concrete Institute ACI method as well in these lectures. And so one of the, a series of questions in this assignment was given to you from the Indian Standard Method of Concrete Mix Design. And then there are two other questions from other parts of the lecture. And at the end of this session, we'll be taking any doubts that you might be having regarding the week 6 lectures, right? The first question in this assignment was, what is the minimum grade of concrete required for structure susceptible to severe exposure according to the Indian Standard Code? Is it M20, M25, M30, M35? Minimum grade of concrete required for structure susceptible to severe exposure according to the Indian standards. Yes, can somebody answer this question? Severe exposure condition. What is the minimum grade of concrete recommended by the Indian standard? I have allowed your microphone, so you can just unmute yourself and speak. Yes, anyone of you knows the answer to this question? All right. The correct answer to this question is M30 grade concrete. And this is the table 5 of the Indian Standard IS 456 2000. And the table 5 tells us about the minimum cement content, the maximum water to cement ratio, and minimum grade of concrete for different exposures of normal weight aggregates of 20 mm nominal maximum size. So 20 mm is the maximum size of aggregates allowed for the application of this table number 5. And the exposure conditions are given from mild till extreme conditions. And all these three parameters, the minimum cement content, maximum free water to cement ratio, and the minimum grade of concrete, have been listed out for the plain concrete, meaning PCC, and reinforced cement concrete, RCC. And you can see that for severe exposure condition, the minimum grade of concrete for PCC is M20, and the minimum grade of concrete for structural concrete, it has been mentioned that structure, so it is going to be RC concrete, and that is M30 for severe exposure conditions. So the correct answer to this question is M30, right? Moving on to the second question. The second question goes, what is the target mean strength for M25 concrete as per the Indian standard? And the standard deviation is given as 5 megapascals. So the grade of concrete is given. Can you tell me what is the strength mentioned in the grade of concrete? Which strength is mentioned as the grade of concrete? Yes, someone? Divya, Vidya, do you want to answer this question? You need to calculate the target mean strength for M25 grade concrete, and the standard deviation is given as 5 megapascal. All right. The strength mentioned in the grade of concrete is always the characteristic compressive strength at 28 days. So this is FCK, 25 megapascals, and we know that characteristic means characteristic compressive strength is that strength above which at least 95% of the results lie from a given test of your specimen results. 95% of the compressive strength results of your of the set of your specimens should lie above this strength. So this is the characteristic compressive strength, right? I'll just mention over here 95% of the test results should be greater than or equal to FCK, right? And mean strength is, target mean strength is, as we know, it is the mean of all the results, and therefore at least 50% of the test results should be greater than that of target mean strength, right? In order to calculate the target mean strength, so FC, let us say, or FC equals FCK plus 1.65 times sigma. This is as per the Indian standard IS 10262 2019, right? So 10262 2009 had only the provision of 1.65 times sigma, but in the case of 10262 2019, it has been modified, and there are two ways of calculating this. One is by the standard deviation sigma, which I mentioned, and the other is by FCK plus X. X is a factor which takes into account both the standard deviation and the 1.65 factor as well. So I have taken this table from 1026 to 2009, and here is the assumed standard deviation for different grades of concrete. And here it is mentioned that M20 for M25 concrete, it is generally 4 megapascals, but in the given question, we have been given the sigma value as 5 megapascals. So we'll just go ahead with that. So FC will be 25 plus 1.65 times 5, and the value will come out to be, so it will be 33.25. The correct answer to this question is 33.25 megapascals. All right. Okay. Now for the questions 3 to 6, you have been given with a problem statement. The problem statement is you have to design a concrete with 30% fly ash in cementitious material for a 28-day target mean strength of 35 megapascals. The cement content, the water content, the fine aggregate content, and the coarse aggregate content for the control mix for same 28 days target mean strength, which is 35 megapascals, are given 375 kgs, 200 kgs, 678 kgs, and 1155 kgs, respectively. It is known that for the amount of fly ash mentioned, the water reduction is 15 kg per meter cube for the same workability. We have also already studied this in the previous sessions as well. When we include fly ash in the mix, due to its spherical morphology, it produces a ball bearing effect, and therefore the workability is improved when we introduce fly ash in the mix. So, since the workability is improved, the other way to say it is for the same workability, we can reduce the water content. And therefore, it has been mentioned for this 30% replacement of the cementitious material by fly ash, the water reduction can be gone up till 15 kgs per meter cube. Assume a value of zero point 0.3 for K factor and reduction in weight density of concrete due to reduced water content and introduction of fly ash in the mix is 40 kgs per meter cube. So, with the introduction of fly ash and due to the reduction in the water content as well, the whole bulk density or the wet density, including the water as well, of the concrete after mixed is reduced by 40 kgs per meter cube. You have been given with this data. So you have to calculate the following for the trial mix with fly ash for same workability, same maximum size of aggregate, and same zone of sand. So the aggregate properties are same as that of the control mix. The maximum size of aggregate and the zone of sand is also the same. And the first question, question number 3, is you have to calculate the water content in the new mix. All right. So I'll just highlight all the points over here. 30% fly ash and target mean strength of 35 megapascals. Cement content, water content, fine aggregate content, coarse aggregate content has been mentioned. 15 kg per meter cube reduction in water content. Zero point 0.3 is the K factor, and 40 kgs per meter cube reduction in the wet density of the fresh concrete mix. Same workability, same maximum size of aggregate, and same zone of sand. All right. Now you have to calculate the water content in the new mix with containing the fly ash. Has somebody calculated this value? If you have calculated this already, you can share the answer, or you can just briefly tell me what is the way to proceed. Yes? I'll just write down the parameters. Till then, if you have the answer, just unmute yourself and speak. This is for the control mix. Cement is 378 kgs per meter cube. 378 kgs per meter cube. Water is 200 kgs per meter cube. Fine aggregate is 678 kgs per meter cube. Coarse aggregate is 1155 kgs per meter cube. Alright, and for the new mix, fly ash, I'm mentioning fly ash content as F dash equals 30% of cementitious material. Water reduction is 15 kgs per meter cube. Yes. K factor is 0.3. And reduction in wet density kgs per meter cube. Alright. Now the new water content is pretty straightforward. It is actually mentioned that due to the introduction of fly ash, we can reduce the water by 15 kgs. So W dash will be W minus 15 kgs per meter cube. So that will be 185 kg per meter cube. Right? This is the first answer to this question. Just have to reduce the water for the fly ash. The second part of this question asks us cement content of the new mix. What is the cement content? How do we calculate the cement content? We already know the water content. Now we have to calculate the cement content. We know the fly ash content. It is 30% of the total cementitious material. And we know the cement content and the water content in the original mix. Now how do we calculate the cement content in the new mix? For this part of the question, you have to focus on this term, same workability. You want to achieve same workability in the original mix and the new mix. Alright? How do you calculate the cement content? Can somebody tell me the procedure to do it? How to proceed? We have been given with this data set. So this is C, this is W, this is F dash, this is W dash, and new cement content will be C dash. So what is C dash value? They are asking us. Yes, how do we proceed about it? All right. We know that for the same workability, and since we are not using any super plasticizers, so for the same workability, the water to cement ratio in the original mix can be equated to the water to the cementitious material or binder ratio in the new mix. All right, because we want to achieve the same workability. So the water to cement ratio in the original mix was 200 divided by 378, right? This is by weight. So 200 divided by 378 equals water dash, which is the new water content, divided by the total binder will be C dash, which is the cement content that we have to find out in this question, and the fly ash content F dash, right? Now we already know that W dash value is 185, right? So this equals 185 divided by C dash plus F dash. And then we'll get an equation for the C dash and F dash value, right? What will that be? C dash plus zero point 0.3 F dash equals 340, sorry, 349.65. This is equation 1. And in this case, both we have to find the fly ash content and the cement content. So both are unknowns. How do we get another equation? In order to find out the new cement content, you have to know another equation from which you'll be able to find out. Which other equation can we use? What other data do we have? It is the replacement of cement with fly ash. So fly ash is about 30% of the total cementitious material, the total binder content. That means, all right, sorry, this is actually, I forgot to do this. I actually mentioned it. This is actually not the correct way to do it. So water to cement ratio of the original mix can be equated with the effective water to binder ratio of the new mix. Now, by effective, what I mean is this was 200 divided by 378. We have to include the effective cementitious efficiency of the fly ash in this water to binder ratio. So W dash divided by C dash plus K times F dash, and K is the K factor, that is the effective cementitious, and this will vary from fly ash to fly ash, efficiency of the fly ash. And we have been given K as, so K is equal to zero point 0.3 and W dash equals 185 kgs per meter cube. We can substitute that in the equation, and then we can find this equation. C dash plus zero point 0.3 F dash will give us 349.65, right? So that will be equation 1. And the equation 2 will come from fly ash F dash content in the total cementitious material content, So F dash divided by C dash plus F dash equals 0.3. 30% replacement in the total cementitious materials content. So that will give us 0.3 C dash minus 0.7 F dash equals 0, right? Now if I just divide all of it by 0.3, you'll get C dash minus 2.33 F dash equals 0. So this is equation 2. Just move to the next. So this is also the question 4 was also related to this part. So I'm using this slide as well because we have to calculate the fly ash content and the cement content. And from these two equations, equation 1 and 2, we'll be able to calculate the fly ash content and the cement content, both of them. Equation 1 and 2, we can calculate as 0.3 F dash if we add both of the equations. Plus 2.33 F dash equals 349.65. From that, we can calculate F dash equals 132.94 kgs per meter cube. So we'll just approximate it to 133 kgs per meter cube. So fly ash content is this much in the mix. And since we know that the fly ash content, we can put it in equation 2 and find out the total cement content. So cement content will be 2.33 times the fly ash content. So that will give us 309.75 kgs per meter cube. So we can approximate it to 310 kgs per meter cube. So this is the cement content in the new mix. I'll just mention it over here. Fly ash content in new mix, and this is the cement content. All right, 133 kgs per meter cube and 310 kgs per meter cube. Hope that is clear to you. So for calculating the cement content and the fly ash content, you need to know that the workability is same. Oh, did not get. Somehow it did not erase properly. I guess, do we have it on here? No, none of it got written. Oh, I'll have to write it again then. I'm so sorry. This probably got malfunctioned or something happened, and none of it is there on the slides. This is 4, this is 5, and this is question 6. Okay, I'll just quickly write down everything again because we missed it. So for the same workability, water to cement ratio original can be equated with the water to binder ratio in the new mix, right? So that will be 200 divided by 378 equals water dash, which is the new water content, divided by C dash, which is the new cement content, plus K times, which is the K factor, F dash, right? So this K is K factor, which is the cementitious efficiency of fly ash. And we know that K is given to us as zero point 0.3, and the new water content we have already calculated it out in the previous question, that is 185 kgs per meter cube. And from that we can get our first equation of this problem, and that will be C dash plus zero point 0.3 F dash equals 349.65. That is our first equation. And we know that F dash divided by C dash plus F dash equals 0.3, 30% fly ash replacement in the total cementitious materials content. And from there we'll get another equation, which is, and just directly write it out here, C dash minus 2.33 times F dash equals 0. So that will be your second equation. From equations 1 and 2, we get that 0.3 times F dash plus 2.33 F dash will give us 349.65, and therefore F dash content will be 132.94 kgs, which can be equal to 133 kgs per meter cube of concrete, right? Now F dash is equal to 0.133 kgs per meter cube of concrete, and from that we can calculate the C dash value as 309.75 kgs per meter cube of concrete. We can approximate this to 310 kgs per meter cube of concrete. So that is the value of cement content and the fly ash content in the total mix, in the new mix. So this is the fly ash content, and that is the cement content in new mix, right? 133 and 310. Moving on to the sixth question, we have to calculate the fine aggregate content of the new mix. Now, how do you calculate the fine aggregate? You have already found out the water content in the new mix. You've already found out the cement content and the fly ash content, the total cementitious materials content in the new mix. You know all the values of the, the weight values of all the contents of the original mix. Now, how do you calculate the aggregate content in the new mix? How do we, anyway, not just for this question, how do we calculate the aggregate content once we decide the water content and the cement content? we first decide on a coarse aggregate to total aggregate ratio, right? So from the Indian Standard Code, I'll just check if it is open in my desktop right now. Yeah, it is here. So from the Indian Standard Code, IS 456, we can first calculate the C by A ratio, not this one. Yeah, this is the mixed from not from the IS 456. This is from the mixed design code 10262 2009, and I have the 2009 version of it. If you have the 2019 version, the newer one, you can also use that. But I mean, at least not this value is different in the new standards. So this value is same in the new standard as well. In order to decide the volume of coarse aggregate, you have to go to the table 3 of the Indian Standard IS 10262. And this is volume of coarse aggregate per unit volume of total aggregate, which is also called as the C by A ratio, coarse aggregate to the total aggregate ratio. And for different zone of fine aggregate, it is mentioned. Zone 4, Zone 3, Zone 2, Zone 1. And the nominal maximum size of aggregate is also mentioned. So for you need, in order to calculate the coarse aggregate to the total aggregate ratio, you need to know two values. One is the gradation of your sand and the zone in which your sand falls in. Zone 3, Zone 4, Zone 2 or Zone 1. And you need to also know the nominal maximum size of aggregate in your given mix. And based on that, you'll be able to calculate. Now, once you know the coarse aggregate to the total aggregate ratio, you have to conserve the volume. So by volume conservation, I mean to say that you have to calculate the total uh, weight proportions of each of the constituents in your concrete mix for 1 meter cube volume of concrete. Now you already calculate the water content, you already know the cement content, and you know the specific gravities of all the materials, the cement, the aggregates, the meaning the fine aggregate and the coarse aggregate, water, and then if you're using any chemical admixtures, then you need to know the specific gravity of those two. So once you know the specific gravities of all of them, then you can calculate the volume of aggregates by conserving the volume to 1 meter cube. Now once you calculate the volume of total aggregate, from that you and from this value of volume of coarse aggregate to total aggregate ratio, let it be, let's say 0.64 or something. So based on that, you'll be able to calculate the volume of coarse aggregate and the volume of fine aggregate in the total aggregate mix. Now since you know the specific gravities of both the types of aggregates, you'll be able to calculate the weight content of each of the aggregate types. And this is the generic procedure how to proceed once you have decided on the water content and the cement content in the mix, how to proceed in order to calculate the all other weight proportions in the concrete mixture. Now, if we come to our given question, how do you decide on that? How do you calculate the fine aggregate content? We have not been given with the coarse aggregate to the total aggregate ratio. We do not know the maximum nominal size of aggregate, nominal maximum size of aggregate, or the zone of sand. But what we have been told is the maximum nominal size of aggregate MSA is same as the original mix. The zone of sand is same as the original mix. All right. Now, if the MSA and the zone of sand is same as the original mix, then the coarse aggregate to the total aggregate ratio of the new mix will also be same as the original mix, because this value depends on these two parameters, right? So now we know that the coarse aggregate to the total aggregate ratio is same as that of the original mix, and we'll start from there in this question, right? And just write it down over here. MSA new is equal to MSA original. Similarly, zone of sand new is same as the original, So from table 3 of IS 10262 2009, C by A ratio of new is also equal to C by A ratio of the original, and this C is course aggregate. So I'll just mention CA by TA. CA by course aggregate to total aggregate ratio is same as that of original, right? Now I'll just C dash by A, total A dash, right? This is CA and C dash TA dash. So we have our first equation, CA dash divided by TA dash equals the uh, the same course aggregate and the total aggregate content of the old mix or the original mix. And how much is that? The course aggregate was 1155 and fine aggregate was 678. So we'll move ahead with that. 1155 divided by 1155 plus 678, right? And that will be how much? This value will be um, now we know that total aggregate is equal to CA dash plus FA dash, which is the fine aggregate in the new mix. So I'll again break it down to like this: CA dash plus FA dash equals this value, and from this equation, if we just substitute all of that, we'll get the first equation as 678 CA dash minus 1155 FA dash equals 0. If we do the calculation, you'll arrive at this expression, and this is the first equation. Now, but these two, both of them are unknowns, right? CA dash and FA dash. How do we arrive at the next equation in order to solve this one? The values of coarse aggregate content and the fine aggregate content in the mix. We don't know the ratio. We just know that the ratio is same as that of the original mix. And from that, we arrived at this expression. What other data can be used in order to calculate the arrive at another expression in terms of coarse aggregate and fine aggregate content? Yes, any hints? Let's look at this. We have the total weight proportions of the control mix, and we know that the wet density is reduced by 40 kg per meter cube in the new mix, right? So this weight proportion in the control mix, this is for what volume of concrete? For 1 meter cube of concrete, right? This is per meter cube. Everything is per meter cube. So if we add up the total weight of all the constituents of the control mix and divide it by 1 meter cube, we'll get the wet density of the control mix. Yes, all the combined weight of all the constituents of the mix divided by the volume of the mix, which is 1 meter cube, will give us the wet density of the control mix, right? So we'll do that. So I'll write over here wet density of control mix equals 200 cement, 378, 200 water, 378 cement plus 678 fine aggregate plus 1155 coarse aggregate kg per meter cube divided by 1 meter cube, and that will give us, sorry, this is total kgs divided by 1 meter cube, and that will give us the the sum of this is 2411 kgs per meter cube, right? So that is the wet density of the control mix. Just put a bar over here. Now we know that the new wet density is 2411 minus 40 kgs per meter cube. So that will give us 2371 kgs per meter cube. And we already know the water content, the fly ash content, the cement content. So if we subtract that, then the rest of the weight proportion will be for the total aggregates, right? So that means I'll just write this expression Ca dash plus Fa dash, which is the total aggregate, will be equal to 2371 minus, we calculated the water content to be 185, we calculated the fly ash content to be 133, and the cement content was 310. So this will give us the total aggregate weight. So that is another expression, Ca dash plus Fa dash equals 1743. So this is equation 2. And from this, we'll be able to calculate the new values of coarse aggregate. I'll just write it over here. New mix, coarse aggregate, Ca dash will be equal to 1098.29 kgs per meter cube, or we'll just assume it to be 1098 kgs per meter cube. So this is Ca dash, and the rest from the total aggregate value will be fine aggregate. So fine aggregates then will come to be Fa dash equals 645 kgs per meter cube, right? So Fa dash should be 645 kgs per meter cube. Just bold, make it bold so that it is the answer. Right? This is how you're going to calculate when you're substituting the some part of the cementitious material in your concrete using fly ash or any other supplementary cementitious material. Now this is a manual way of doing it. You can just automate in an Excel sheet or any other software, and this can be done in seconds. So this is the manual way to calculate the weight proportions. But yeah, generally on sites we do it using Excel sheets. So yeah, that brings us to the end of the assignment 6 questions. If you have any doubts regarding these questions or any of the assignment problems, then now is the time to discuss. Or else, if you have any doubts regarding the week 6 lectures or any of the previous lectures, any of the sessions that we have had previously, then you can shoot them and we can discuss now. The session will go on till 8 p.m. And we can utilize this time to discuss any doubts that you might be having. If you don't have any doubts, then you are free to leave the session, or else you can stay and we can discuss your doubts. Queries. I hope the mixed design calculations were clear to you, how we arrived at the answers, because none of these answers had any options to them. So I hope explaining the procedure of calculation will be beneficial for your learning as well as for your I mean if any such question comes in the final exam of this course, the certification exam. So, save this once because I already lost it. Yes, any doubts? Any queries? Anyone has any doubts or queries? All right, I'll just mute myself. If you have any doubts, then please raise your hands or unmute yourself and speak, and I'll be right here. I'll respond to you guys. All right. If you don't have any questions, let's close the session for today. We'll meet again on next Monday from 6 to 8 p.m. Thank you.